Hi everyone, I welcome you to the presentation of this lecture. Here we are going to discuss how to convert a hardware circuit to a PLC. Okay, so I'm going to be talking about three components. There is a hardware symbols here. We are going to be looking at the actual component and the PLC symbol. So we've got this one. This is a start push pattern. A start push pattern in the hardware symbol, it looks something like this. In PLC, all the normally open contacts, they are represented by this. And then in PLC, all the inputs are labeled X. So whatever you see X in PLC is an input. An input is basically anything you're able to interact with. Something you can press is an input. Then an output is something which is reacting from the input itself. Okay, we've got the stop push button, which is an input symbol as well. It looks like this as the actual component. In hardware, it looks like this. And as PLC, it looks something like this. Okay, this is also an input symbol and it will bear the name X. We've got the contactor. So the contactor, the actual symbol looks something like that. The actual component looks like that. The symbol for a contactor. So for example, if we are looking at the contactor, limit M, contactor M, for the hardware, it looks something like that and it will have the name itself M. That's the coil for that contact. In PLC, contactor coil is represented by that. That's the symbol. Then we have, so in PLC, all the outputs are labeled Y. So a contactor, you really can't press a contactor. You need to press a switch, which is an input symbol. And then from that, it will make a contactor to react. So a contactor is an output symbol. And all the outputs in PLC are represented as Y. So we've got X, which are the inputs, Y, these are the outputs. Of course, here we are calling it contactor M. In hardware, it has that, but in PLC, we are only dealing with X and Y. X being the inputs, Y being the outputs. We've got the overload. So the overload is something you can interact with. You can press it to trip it. So it's an input symbol. And it has two terminals. It has got a 95, 96, and 97, 98, which are normally open and closed. Here, I'm talking about the normally open symbol. So the normally open of a contactor, something which is like that. Here it will be like that. If we were to discuss the normally closed, if you look at the component analysis, the lecture I showed you, it looks something like that. And in PLC, yeah, you have something like that. But because you interact with it, of course, it's X as well. Okay, so this is the normally open of a contactor. For the close, it will be something like that, and it will have X because it's something you interact with. And then we have an auxiliary. These are auxiliary contacts. They are just meant to increase the terminals of a contact. So they've got normally open and normally close. So that's the normally close and the normally open. In PLC, normally open and normally close, it's just like that. But these are output symbols because you don't press an auxiliary. Something you can't interact with. It will react based on whatever the circuit obeys. So for the normally open, it will be something like that, and it will have Y because it's an output symbol. And then you've got the timer. So for the timer coil, they're calling it T, of course. And the hardware, you have something like that. It will be called a timer. In PLC, it will look just like a contact, but it will have T, meaning it's a time. The auxiliary terminals, it's the same, just like this. They will have that. And those are output symbols. So basically, these are hardware symbols. These are the actual components. If you have to wire, these are the things you see. And these are the PLC symbols. So let's look at an example. Okay, so we are looking at an example now. So the question is saying transform the given circuit to PLC. So this is the hardware circuit. You're transforming this one to PLC. So as you are transforming a circuit, Just need to note which ones are your inputs and which ones are your outputs. In the previous slide, I was just showing you the symbols themselves. So as you can see, we've got a live wire here, which is this one there. On the live, it's passing through the fuse and then giving the stop push button. The stop in PLC is represented by that. Then it's going to the start push button, which is that one there. From there, it's giving the coil, that one. Then from the coil, it's giving the overload, normally closed, which is this one there. Then next, you've got this hold on contact, which is normally open. This one is sitting parallel to the start push button. Then from there, we have this normally open. Then from there, you are giving the stop push button, which is this one. Then you are going to the start push button, which is a normally open symbol. From the normally open, we are giving the coil, which is this one there. From there, we are giving the normally close. And then you've got that hold on contact down there, which is normally open. You have that one there. Then you've got these two normally open. So we have those which are in series. And then from there, we have the stop push button. In PLC, a stop push button is a normally close. Then we are giving the start push button, which is this one there, normally open. That one there. From there, we are giving the coil. That one there. From the coil, normally close of the overload, which is that one. And then we have the hold on contact, which is normally open, just in parallel with that start push button. That's the one we are having. Then we've got this normally open. From that normally open, we are giving the stop push button, which is a normally close, and then the start push button, which is normally open. Then we are giving the coil. From the coil, we have the normally close of the overload. And then we've got these two hold on contacts. So we have this one, which is normally open, and the other one there, trying parallel with those terminals. And then every time PLC should end with that parameter, which is end. And then we've got a neutral, which is this one there. We are connecting that one, and then we are ending it as end. But this is not enough. Now we go to the nomenclature, which is the most important. You need to name these. So as we are naming your PLC program, you start naming it from the left going to the right. So all the inputs should be labeled X, all the outputs should be labeled Y. And then we follow that. So you've got the first input there, stop push button. It being the first, we can call it X0. Then from left, we are going to the right. All the inputs you are seeing, for so long as they are different, they should be increasing in number. X0, X1, just like that. So this is the first input, stop push button. You can interact with this one. You have the start push button. It's a different component. We can call it X1. Then we've got this overload. You can interact with the overload. So this one will be X2. Then we've got this stop push button, something you interact with. So from the left, all the inputs start increasing. So you've got this input, that input, and that input. So from X3, you go to the next, which is X4, that one X5. Then you go to this line. How many inputs do you have? You've got this stop push button, start push button, and the overload. So if this was X5, start increasing. This will be X6, X7, and X8. When you go down here, how many inputs do we have? We've got this stop push button, start, and the overload. So since we ended at 8, the next will be 9. So you have 9, 10, and 11. So with this, we are done with the inputs. Then we go to the outputs. So outputs, these are terminals which will react upon pressing the input. So if you look at the first line there, how many outputs do you have? You've got this coil, which is an output, because once you press, this guy will react, which is the coil. So since it's the first output, we call it Y0. And in hardware, you've got this 1M. So anything sitting on that contactor will be called 1M. So if this is the contactor coil 1M, this contact is sitting on that contactor, and anything else labeled 1M is sitting on that. So you've got this one, this one, this one. All these guys are sitting on that contact. But in PLC, since this was Y0, anything which was labeled 1M here should be Y0 here. So this guy will also be Y0, which is that one. This one will also be Y0. But this one will be Y0. So we are done with this output. This output has got these terminals. All these are sitting on that contact. You look for another output. So if you go in this line, you've got this coil, which is an output. So since this was Y0, this will be Y1. If this is Y1, here you have 2M. So anything labeled 2M, here it's Y1. So if this is the coil 2M, you've got this 2M, you've got that 2M, you've got this one 2M. So all these will be called Y1 in PLC. So you've got that one, and that one. Okay, then you go to another output. Then another output we have this one, which is 3M in hardware. That 3M in PLC, we had Y0, Y1. So this one will be called Y2. And anything labeled 3M in hardware, which is this guy here, that guy there, in PLC they'll be called Y2. So you have that one as Y2, that one as Y2. Then we've got the last output, which is 4M. So 4M, which is that coil, all the terminals sitting on that contactor, I think it's just this one here. So this one is 4M, this was Y2, so meaning that will be Y3. You have Y3. Which other terminals Y3? It's this guy 4M there, which is that one there. So with that said, you would have named all the inputs and outputs in this PLC. So converting a circuit from hardware to PLC, it's not really difficult so long as you know the nomenclature as well as the actual symbols. In hardware, what are they, and in PLC, what are they? Otherwise, this is how you convert a circuit from the hardware to PLC. Thanks for watching.